James Webb Space Telescope has a number of objectives. Finding exoplanets that are capable of supporting life and where we might someday be able to look for evidence of it is one of the most crucial. Finding another planet that is similar to Earth may prove to be harder than you think, because habitability is a complicated idea. In this video, we will discuss the discovery that the James Webb Space Telescope will make regarding Proxima B. Before anything else, hi there, and welcome back to the Discover Space channel, where we explore life here on Earth and life beyond it. Be sure to subscribe if you haven't already, and let's get on to the video. There is a beautiful star system about 40 light years from Earth. NASA made international news 5 years ago when it revealed that it and a number of other partners had discovered a plethora of Earth-sized planets circling well within the habitable zone of a single star. The TRAPPIST-1 system received widespread attention as a result of this discovery. Since that time, scientists have all been excited to learn more about these nearby worlds that might resemble our own planet Earth. Enter the James Webb Space Telescope, which will initially concentrate its efforts on TRAPPIST-1 system in its research programs. The short-term objective of the research is to find out if there are any planets in the TRAPPIST-1 system that have atmospheres. Long-term objectives include developing a technique for looking for biosignatures that might point out to the evidence of life on any planet. To understand universes that are just not similar to our own involves overcoming a great deal of challenges. Recent modeling suggests that a planet's climate is not solely determined by its distance from its star and the makeup of its atmosphere. A planet's potential habitability is also greatly influenced by how much land is present on its surface. Evelyn McDonald, a doctoral student at the University of Toronto in Canada, presented her research findings on exoplanets at the National Astronomy meeting. The researchers' simulations were based on the analogous in-size exoplanet Proxima Centauri B, which is close by. Similar to TRAPPIST-1, Proxima Centauri, a red dwarf, can also be found nearby. Planets can orbit much closer to these stars while still being in their star's habitable zone, because they are smaller and cooler than our Sun. Like other planets in the TRAPPIST-1 system, Proxima Centauri B is tidally locked. This implies that there is always a face of the planet facing the star and a side of the planet facing out into the space. Although none of the planets in our solar system have anything remotely similar, this behavior can frequently be found on exoplanets. Once upon a time, it was generally known that Mercury was tidally locked as well. But it turned out that things were actually quite different. The Moon, however, is orbiting our planet, and we have noticed that one side of it always faces us, while the other, its dark side, always faces away from us. The habitability of tidally locked exoplanets may be affected because astronomers expect that one side of the planet will be significantly hotter than the other. However, this problem might be lessened if the atmosphere had winds that evenly distributed heat throughout the planet and made it a suitable environment for life. The day side of a planet is the side that is always facing the star, while the night side of a planet is the side that is facing away from the star. McDonald's team looked into how a planet's day side's amount of land affect the planet's temperature. They compared two scenarios, one where land was situated in the middle of a circular ice cap, and the other where land was situated in the middle of a liquid ocean on a spherical continent. The model showed that when a planet had a higher percentage of land, there is much less precipitation, higher temperatures, and a wider temperature range between the day and the night sides of the planet. A planet's rainfall and cloud cover also increased where there were more bodies of water present. Because ocean water can freeze at any time, the amount of ocean water that is liquid at any given time affects both the global temperature and the quantity of water in the atmosphere as a whole. The researchers found that the distribution of that land could alter the average surface temperature of a tidally locked planet by up to 20 degrees Celsius, even when the total amount of land remained constant. Even though the total area of the land remained unchanged, this was the case. According to McDonald, this is a sizable climate variation that was merely brought on by shifting the amount of land and its location. Now the question lies, is Proxima B capable of sustaining life like Earth? Well, no one has actually seen this distant planet, so it's kinda difficult to answer. Scientists have simply found that Proxima B, which is located approximately 4.2 light-years from Earth, is exactly where it should be by observing the periodic slight variations in the color of Proxima Centauri. Proxima B orbits its star with a bare minimum of an 11.2-year revolution because it is tidally locked to its star, only one side of which is ever illuminated, and it is always facing Proxima Centauri. Red dwarf stars are not quite as hot as yellow dwarf stars like the Sun. On the other hand, Proxima B might have liquid water, and its atmosphere could distribute heat to the planet's dark side while protecting it from the Sun's rays. Harvard's Avi Loeb and astronomer Laura Greenberg recommend using NASA's James Webb Space Telescope. Loeb hypothesized that if a rocky planet like Proxima B had an atmosphere, it would absorb light from its star and re-emit it as an infrared radiation. The JWST was developed specifically to study infrared light, by the way. The JWST can take infrared images of the Proxima B's surface to look for patterns that might show that whether or not an exoplanet has water or an atmosphere. The suggested strategy might just work. But there are many other factors to take into account. Ed Turner, an astronomer at Princeton University, claims that the existence of an atmosphere may not always be a sign of life. Proxima B might resemble Venus because of its intense heat and atmosphere, which is 90 times thicker than ours. But Loeb and Greenberg's hypothesis is the only possibility we have for even a sliver of answer regarding this Earth next door. The James Webb Space Telescope will map the atmospheres of the exoplanets. Exoplanets are planets that have been found to orbit stars other than the Sun at a really great distances from Earth. For instance, the closest exoplanet to us, Proxima Centauri B, is 4.2 light-years away from us. The planets of our solar system appear as bright dots in the unaided eye. While using a telescope to make these spots visible from the stars is possible, where we can see the great spot on Jupiter, Saturn's rings, and the Martian ice caps. Although these types of occurrences are predicted to exist on exoplanets, we are unable to directly resolve their surfaces because of their great distance from Earth. However, there are methods to more fully comprehend their atmosphere. Isn't it exciting to even think about the possibility of a human civilization on an exoplanet, or even a planet other than ours? What do you think? Let us know below your thoughts on this amazing possibility. And if there are any other cosmic revelations or cosmic mysteries that you'd want to explore next, let us know. And we'll see you then.